Thanks for the introduction. I try my best to be more than a second-rate Arne and just give you a different experience. So, yes, I'll just wait for everyone to sit down. Yes. Okay, so I want to start with a slide that we have all seen before. I was very inspired by this in yesterday's talk, because I felt like, I think I really don't need to convince this audience why this is a good approach, because what we do in GF is pretty much this. So okay, so why does this matter? We have the Mexican hat problem exactly in natural language, just like in formal mathematics. We have some application domain, mathematics or healthcare or weather reports, but then all of the long tail, that's stuff that is exactly like the drudgery. You have to implement verb conjugation. You have to make sure that we have to do this. Wow, you have really nice chalk, by the way. I'm envious. And you really don't want to implement this over and over again for each different domain, or stuff like I don't know. I'm staying in Drancy. My train stop is called Le Bourget. But then if I want to say the station of Le Bourget, I can't just do this like this is not valid French, so I really like these colors. We have to have rules that make sure that this is implemented like this. And that's exactly what GF is for. So I was told that half of the audience has seen multiple presentations of Arne, and other half has no idea what the hell is grammatical framework. So it's a bit of a challenge here, but bear with me. So it's a formal grammar framework where we intend to formalize the grammars of the world and make them available for computer applications. Also, Arne has told me to say hi to everyone. He said, say hi to everyone I know. I'm I don't know who you know, because I don't know anyone. But yeah, we have a lot of languages. This could be orders of magnitude more, but this is to get started. Okay, so that was that. If you want to get back to writing your emails, that was the elevator pitch. If you want to continue, I'm happy for the attention. So, okay, multilingual grammar applications. What does that mean? We have several languages, and they need to somehow be translations of each other. We know these are the same thing. We have other things than natural language. Maybe this is also a multilingual grammar application. Also, if you can see the year there, we have been doing this for a while. I mean, this was before my time. I've been around in the GF community since 2010. But yeah, Arne has been going on since 1998. This was one of the early applications of GF. How do we do it? We do it with an interlingua. So we parse from one language to an intermediate representation, and then we linearize it, and that's how we get translation. And what we use as the intermediate representation, we have something we call an abstract syntax. And then each of these languages corresponds to a concrete syntax based on it's a linearization of the abstract concept, we want to say. And so unlike some other talks here, this is 100% handwritten, so there is no machine learning whatsoever in this approach. But, some of you think it's a good thing, others think it's a bad thing, but take what you want out of that. So a bit of a theoretical background. I think this audience, I usually give talks to audiences that have no idea what a logical framework is, but I guess I can tell you that GF is a logical framework with some added grammar. The abstract syntax is that. It's based on multilingual type theory. We have, actually, I mean, we used to have much more ambitious like type things. It's becoming a more of a mainstream natural language processing thing, but it has its type theoretical roots there. The concrete syntax is something called parallel multiple context-free grammar. Again, I don't really know if you're into formal grammar, but like this is the Chomsky hierarchy, and where are we? If we zoom in right on the border of context-free and context-sensitive. Like this is actually very populated by, that's where we are officially called mildly. We are just between mildly context-sensitive and context-sensitive. Like there is, as far as I know, there is even no general term for what we are. But this is like this tiny spot is very populated by different computational linguistics formalism. I got these slides from a different talk for a different audience, so if you don't know what these things mean, just ignore them. They are things that are like GF, but you just didn't know their creators, so you did not invite anyone from these communities to give a talk. But there could be an alternative universe where there could be someone who, I don't know, did a PhD on categorical, combinatorial categorical grammar, yes, or tree adjoining grammar, or heteronym and phrase structure grammar. But now this is the universe where you people knew Arne, and that's why there is a GF person giving this talk. Also, this is from a whole different talk. So again, if you don't know these persons, just ignore them. But since I have mentioned the term interlingual, what do I mean by that? It's, we can say that a programming language compiler is an interlingual because it is the intermediate representation between the high-level computer code and the machine code or assembler. Or I mean, on the other hand, maybe the term interlingua brings to mind some things like, some people, some hundreds of years ago, who had very ambitious goals of finding the universal truth and by basically discovering the encyclopedia. But yeah, what GF is we are covering these to the mid-range of the spectrum. So we could even say that basic language resources that implement this type of low-level rules, that's towards the lower end, whereas some application grammars, which I'm going to explain the concept eventually, it's more in the, if we have good semantic primitives, we can produce better translations, more idiomatic translations. So that's the range of interlingua that GF sort of covers. Okay, so I was asked to start with a high-level overview, and also I try my best to not repeat the Informath talk, which many of you have seen. So let me just talk about some previous applications. Well, okay, controlled natural language translation, that's the obvious one. It has been mentioned many times, so maybe I don't have to talk too much about it, but just to show that there's people other than us in Gothenburg who are writing papers about GF. I suppose the author of this is probably sitting here somewhere, but as I said, I don't know anyone, so I don't know who you are. Maybe you're writing emails, so you're not actually recognizing this slide right now. But so this is something called conceptual authoring, or what you see is what you mean. So it's instead of just writing natural language text and then getting hit by parse errors, maybe something like we can have some sort of very restricted domain, and then we are controlling, okay, what is it? We're building the thing we want to say out of from high level to more detail. So just we want to say that some place is open. Then, okay, what place is this? Well, it's a disco. Is it great? How do we want to phrase it? Is this affirmative or negative or a question? And we can also make it into an embedded sentence. So like, I know that the disco is open or something. So that's just an example. I mean, this is very kind of a toy example, but I think like the concept really has value. This was some previous research topic by, I mean, well, not just research topic, it was an application together with a company. This was for back in the days when GDPR became a thing, and I think it was a law firm, they wanted to explore all these different documents in different EU languages about the GDPR, and finding like how do these concepts align. So, you know, if you just have the word subject in English, it can mean these different things, and then, you know, it would be very different. You would translate it wrong if you say X is subject to something, and you would say X is sujet to something. That's totally different. So this was like this work was done using GF, parsing it to GF trees. Language learning applications. These are both finished and ongoing PhD projects in Gothenburg. You know, kind of. You know, like if you think like how could Duolingo be better if it knew more grammar? That's kind of the vision here. Question answering. This was also a PhD thesis topic that was in Finland. I'm not super familiar with this myself, but I'm just gonna, as I said, these slides are gonna piece together from different parts, but again, like the same idea that, like, you know, we have a bunch of natural language, we parse it, and then thanks to that structure, we can extract answers to questions. I think, I don't know more about this, so maybe I'll just keep it short. Dialogue systems, again, like this is kind of an example of a controlled natural language for a very particular application. I guess the twist here is just that there is some spoken language there. This was also a student work in Gothenburg at Chalmers. Natural language generation. So this was this was done together with this company called Altran. They have a formal language called Z, and my colleagues, Arne and some other colleagues, made this. They did a GF grammar to informalize the formal language called Z. So I think that was, I was not involved with this research or well this work myself either, but to my understanding it was considered quite successful. So like here's another slide of that. So like I mean this looks pretty much what looks very similar to other formal languages we have seen during this this kickoff meeting so far. So we have some source, and then we generate the English version and the formal. So they are two concrete syntaxes for the same abstract syntax. They can be, a formal language can as equally well be another concrete syntax, not just natural languages. And that's the one you've seen before. This Informath. So this has been Arne's project for the past year or so. I think it's not really affiliated with any research. Like he doesn't have any PhD students or anything working on this. It's kind of just Arne on his own doing this for fun, and like this is the talk that many of you have seen in many occasions. But just to basically. So I mean, this is kind of more of like this is not really an application per se, but it's resources that can be used to then, like it's kind of like another resource library, but instead of dealing with it's like it's a library one level above this level, because like it assumes that okay, we have figured out that le becomes du, and then okay, the next level, how do we do these combinators for mathematic terms? And then maybe we can have some very high level application, like this is kind of what I mean by a high level application. Like maybe you want to have some conceptual authoring for mathematics, and then what you would use would be the Informath library as powering this type of application. But yeah, since half of you have seen it, I'm not gonna talk super much about this. Yes. So that actually fits well with the questions that Makarios just got. So we have not just Arne writing code in his own cave. We have a whole bunch of people. We have our GitHub. We have 40 different contributors over the years to the GF core, which is the compiler and runtime. We have 50 contributors to the resource grammar library. That's the one with all the different languages in the world map. So it's separate. I mean, obviously there is a lot of overlap between these 40 and 50, but it's not like the 40 is not a strict subset of these 50. So, I mean, GF has only been on GitHub for the past, I think, less than 10 years, honestly. So we had a long history of being hosted on darks instead. So there is still like a lot of contributors who are not actually visible here. So, but yeah, I mean, not every one of these, I don't know, 70 people are equally important, but just to say that, it's not just literally Arne writing code in a cave. We have a tiny bit of Stack Overflow presence. Like, I know like 49 questions is not an impressive amount, but like still just, I figure that I'm in an audience that is used to kind of niche applications. So I'm very happy to, I always try to get people to write their questions on Stack Overflow so then I can go and answer them. We have a Discord chat, so like that's, I know people would talk about maybe you like Zulip more, but it's just, I think like, a lot of students, young people like Discord. Like I've been supervising some master students and like they ask me questions on Discord like 3 a.m. or something. And I think it's good that they find me approachable, and like it's better that they ask their question rather than like they don't and then they get stuck and never finish their degree. So yeah, I mean, I think like, if you are planning to use GF in your Malinka work or any other work, so like it is highly recommended, like join the community, say hi, ask any questions, like me or someone else will be usually quick to answer. And especially if it's like one of these very common questions, like, oh, I can't find the GFlib path, like, oh yeah, you need to do that. Like it's something we have seen thousands of times, but since, I mean, we are not, unfortunately, as Googleable as Python or something, it can be hard to find that question on the public web, but just come to our Discord and someone will probably answer. We have also a Google group. I think it's been, I mean, yeah, the screenshot is from yesterday, so it's like, you can see here messages up until January, so it's not like, it's not the most alive, but usually if you post something, people will see it. So I'm including it here, in case you don't like instant messaging, but you like mailing lists. And then we have our summer schools. We had our 9th summer school this summer in Gothenburg. That's this picture right there. And yeah, we've been Gothenburg, Barcelona, this tiny island in Bavaria, Malta, Riga, Stellenbosch, South Africa, online because of pandemic, Tampere, Finland, and then back to Gothenburg. So, I mean, it would be nice to have next one in Paris, for instance, or something, but just saying. Yeah. Okay, that was the high-level overview. I don't know, maybe any questions so far, or should I just save questions to the end? Oh, yeah, okay.
Is this being used, for example, to create things like instruction manuals that show up in 50 languages when you get your box and stuff like that?
I mean, as far as I know, not. But like, I mean, it would be. I think that would be a great application. I mean, if you read the actual instruction manuals, they kind of suck. Like, I think they're just using whatever LLM, like whatever technologies they used before that. But I mean, we used to have. I mean, okay, so when I say we, like Arne started this company called Digital Grammars. I joined it in 2018. Like, it was a very brief window of time where we were very optimistic about the commercial applications of role-based language technology. We used to have this one customer that created like product descriptions for e-commerce. So their customers were, like, you know, any stores that would sell things online, and they used GF for a very brief moment in time, for like 2 or 3 years, but then they switched to like, okay, let's just use LLMs when that became a feasible thing. So I think like it could have very well been a thing, and I think it would have been a successful thing, but just we're kind of small. Okay. Well, let's move on. So I was promised that I can get detailed, like hands-on, dirty, like getting hands dirty. That's what I mean. Okay, so how does GF look like? We have our abstract syntax and concrete syntax. Oh, do I actually have this? Is this the thing that I can use to point at things? Oh, no, what's this thing? I don't know. Is this the thing I can use to point at things? Well, I don't care. It's there. So, yeah, in the abstract syntax we have categories and functions. All the grayed out things are when I said in the beginning that, oh, you know, GF used to have very ambitious typey thingies. We have those, but it's not like implemented in all of the runtimes and all of the bindings to different programming languages. So if you want to write GF and actually use that in some kind of concrete application, you can just pretend that these more advanced typey thingies don't exist. So, categories and functions, right? And then in concrete syntax, we have linearization category, which gives some kind of concrete type, like, you know, a string, or like something like a record. Actually, it is called str, not string. It's an important distinction, or some, you know, other fields of types that I explain soon. And then functions, which linearizations, which are then linearization of the functions. So take a slightly more concrete example. So we have, this is a tiny grammar for a mathematical domain. So say we have our categories are proposition and term, and then we have a function that takes a term into propositions, for instance, is commutative. So then we have the concrete syntax, then this is a very simple example that, okay, we just say propositions and terms are both strings, and then the way to linearize the proposition that a term is commutative happens by concatenating the string is commutative. Obviously, that's not how we do this, but just baby steps at first. So yeah, then some of the more advanced things we have, we can define parameters and operations. So parameters are just like, parameters are like you just define your algebraic data types in GF. And then you use these parameters as fields in these linearization categories. So I can say n is of type number. And then I have first defined, let's say, So that's for instance, a way I could use this. I define a parameter number with the values singular and plural, and then I say that linkat of noun would be, oh sorry, that's a bad idea. Let's say just noun phrase. Noun phrase would be, have a linearization category that, okay, we have a string, and then the number, is it singular or plural? So we would say that, I don't know, a mouse, its string would be, and number is singular, whereas mice So here's an example how we would use these parameters. I just really like this white blackboard, so I want to take advantage of that. It feels very legitimizing to be a teacher and write on Blackboard. Okay, well, other languages, we have languages that are much more complex than English. So for instance, here for French, even if we just want to say that something is commutative, we need to already know the gender of the subject of the sentence, because adjectives agree with nouns in all positions. So, like, you know, a beautiful house or the house is beautiful. So we need another parameter which is called gender, and we give it values masculine, feminine. We would also need, if we want to think of, we want to make like sentences, like in mathematical text, like you want to say like, okay, X is commutative, or let X be commutative, and then you would need the subjunctive mood, so like soit X commutatif or something. Whereas in English you could just like concatenate the word let X be commutative. I'm going to do some live coding, so like all of these things you will see later. So this was also like what Adrian was referring to with the smart paradigms in the GF. So this is an example how we don't, like, you know, we don't just write a full inflection table of every single word when we introduce that into our grammars. We have packaged these kind of morphological builder functions, constructor functions in a different module, and then, yeah, I mean, we just kind of, this is basically regular expressions, like, I mean, yeah, this is literally, literally just regular expressions. So for very many of these, a lot of the time, like, many words are actually quite regular. So if we get like 80% of all the words, we can just use this one argument smart paradigm. It makes it much faster. And then maybe the remaining 20%, we might need to give a constructor operation more forms of the same word, and then it will realize that, oh yeah, okay, that's the irregular word. So like we get like mouse, mice, and not mouse, mouses. But if like, I guess like English nouns, it's way more than 90% of the words that just, you know, it's just like child, children, ox, oxen, mouse, mice, that kind of things that are irregular. So we have implemented all of that. So the Resource Kernel Library comes with this rather high-level API. So it's morphology and syntax. So the operation names are overloaded. You don't have to remember different names. Okay, I want to build a clause. Okay, how do I build a clause? So like, okay, no, phrase an adjective. Like X is commutative, or like the example here, she is old, but it's just the same structure as X is commutative. Or yeah, anything else like MPVP, like, you know, she whatever, she eats bread. So that's, and like, again, like all the language specific details are hidden under this, so you don't have to, like, yeah, you don't have to specifically know details about even things like subjunctive, because it's kind of all implemented in the French resource grammar. So then how this grammar would actually look like is we would define the lin cats. Like instead of writing like this, we just actually, I mean, this thing would be actually hidden in the resource grammar. So can I, if you wipe this off, we would actually be just writing like term NP, and we don't have to know what this NP has eaten there. So now, if you are thinking like, what's the advantage of this as opposed to context-free grammars? Like this is a single rule that we have written here. Linearize the function commutative. We call the MKCL, and then we define our commutative A using these smart paradigms like here, so we just write commutative. And from here, we see that it would match this rule here, so like commutative, and so on. And so this single rule expands in the low-level format then into multiple ones, depending on the language. Or like in the case of French, there's more morphology, more morphosyntax that's happening, so it's the more complex the language, like the bigger the gain, basically. So now we have around 15 minutes to write a grammar, or maybe like 10 minutes and then time for questions. So I have prepared a GitHub repository. Let's ignore this. Okay, so I'm gonna start a grammar. malinka.gf. So what do you want to write a grammar about? We can start with this terms, propositions, X is commutative, just to, but you can, if you want to add some extensions, just think of them and shout out. So abstract malinka. And then I have my cats and fawns. So we had term, proposition. Also, I usually need to add start category. And I will say that proposition is the start category. For funs, we have the is commutative, but we actually also need a function that takes, we need some terms that we can apply it to. So I'm just gonna say, I'm gonna take a string literal. I'm gonna accept any string literal as a term, so I can say this, string term. So now it's a variable. And now we can do the commutative. Term to proposition. Okay, so we have actually, I could already, sorry, this is acting up. Let's start anyone. So I could already actually, I can open this grammar, like malinka.gf. I could generate some trees. With the string literals, it's not like giving me literally infinite amount of string literals, it's just giving me this. So now so far it's giving me the exhaustive amount of trees that A is commutative, or B is commutative, X is commutative, Y is commutative. But okay, so to make it more interesting, we need a concrete syntax. So what I just do is like, I copy the abstract syntax into a concrete one. And then we start filling it in. So, concrete Malinka eng of Malinka. We can first just do the simple one where there are just strings. And then commutative x. Okay. Now if we compile our grammar and we do generate trees, but now we do linearize, we get all of these. Yes. Okay. So that's the string literals are implemented in all the string literals implemented as a record with just a string with the s field. So that's how it's. I actually could have also if I want to do, I could have done it this way as well, and then just say like this. Yeah. Well, okay, maybe this was actually not much clearer, but anyway, like this. Oh, oops, sorry. Whoop. I'm just trying to show you a tree that we have visualization. Oh. Yes. Yeah, so now just, anyway, yeah, so the type of string literals is this kind of record thing, but maybe we can actually just put these back, saying like this, and x++ is commutative. Okay, now we can do yet another concrete syntax. Let's do French and use the reasons grammar library here. So as you can see, we have a GF language server on VS Code, but it doesn't have fancy stuff like clone into a new language. So I'm just using this kind of very unfancy way of copying things into Malinka. I mean, you can see the language server is working because it's giving me it's giving me this warnings here, but like it doesn't have like super many fancy features. Okay, so now we saw this type of, this is like the using the reasons grammar library, and if we want to use that, we need to open something called syntax frä paradigms frä. So these two modules, basically the syntax is giving me the syntactic functions, and the paradigm is giving me the constructors that build the individual words. And now we can say clause and noun phrase. Like I could have said like they come from these modules. So I can just put them there to be explicit. Now the way to make string literals into noun phrases, I can just show you Grammatical Framework. We have the RGL API. I mean, I know how it's called, but I'm just trying to be pedagogical. That's like table of contents. Yes, the symbolic module. Also, we can make like this is even the way it's intended to be used. So we can just create noun phrases out of symbols because they don't have to inflect in any specific way. So we can just raise them into noun phrases directly. So actually for that I do need to open a third module. So like that. And now instead of this plussing blah 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 is commutative. So what I can do, MKCL X MKA commutative. Now it's complaining about something. Oh yeah, that's exactly what it's doing. Thanks. Oh, that's exactly the wrong way around. It's the proposition should be the clause and term should be noun phrase. So yes, now it's stopped complaining. So GF Malinka star.gf. So we can also actually, now that we have the whole resource kernel library, if we do, okay, again we can do this and then linearize, actually with, so we can see it all in one line. So this abstract syntax tree, commutative var A is commutative, A is commutative. Okay, that's not super interesting, but if we want to really look at something like, foo is commutative, we can use this flag table, and we can see that actually, sorry, let me use another flag to make the output look a bit nicer. We can see that there is this whole inflection table of a sentence. Even this grammar, here, we literally don't have anything else than just positive sentence. Positive declarative sentence in the present tense indicative. But we still have this whole bunch of things that we can see that these, we have it past the sampler. We have, the I don't know, does this mean remote past? I guess we have different combinations of future or future anterior, and probably you're not going to need all of these in your application, but that's all that we have implemented in the past 25 years or so that you don't have to. Okay, I had ambitions to adding more constructions to the language, but maybe I should stop here and take some questions, or okay.
So questions?
Yep.
Thank you for the talk. So I have a small technical question.
Oh yeah.
So, do you have any, formal specification of the type system behind that language? I'm just wondering how it's different from simply typed lambda calculus.
Actually, I have a slide about, the short answer is that there has never been any super formal work done about it. It's kind of like how Arne phrased it himself, is we just kept adding things that were nice to have. So we have subtyping and dependent types and stuff, and sometimes, but it would be lovely if some eager PhD student would come and formalize the type system or something. But it's just in practice it's kind of a combination of things that Arne found interesting and cool back in the 90s or early 2000s. So.
Okay, thank you.
Yeah.
Hi, thank you for the talk. A question about conceptual analysis. It seems that there is a one-to-one correspondence between the terms in one language and the terms in another language, and we know that this is not strictly speaking correct.
Okay.
How do you implement that?
Okay, right. So that's the whole major selling point. I think I did a very bad job I apologize so much. Like, I mean, it's okay. So on one level, we have our resource grammar where we implement this very low-level things, like how do verbs inflect? If we want to put together an adjective and a noun in a like if the adjective modifies a noun, how does it agree with it? But then we have the whole big level of application grammars where, like, you know, I mean, let me just do this. Like, okay, so totally new thing. Like, my name is string to prop. Okay, that's a new function. I'm answering your question like this. My name is and for the French one, so we want to say je m'appelle. So that's a different. It's not like mon nom est blah blah blah. It's like I call myself this. So what we would say, so we need to make, let name NP in MKCL INP. I actually don't remember how do I get the reflexive, but I mean just quick demo. So like MK V2 appeler. And then name MP. I mean, I know this doesn't have the reflexive, but like just, and then we just do like linearize. My name is Inari. I mean, yeah, it doesn't have the reflexive because I don't remember off the top of my head how to get it. But does this answer your question? Yeah, I mean, the application grammar is the one that lets us have translation equivalents that are not syntactically equivalent, but are semantically equivalent. So. I mean, yeah, it's like, I mean, if we, like, I mean, we can define grammars at, I mean, I guess you all know the, I don't know, the Vauquois triangle, like I forget which audience I'm talking to, sorry, but like, you know, this, am I doing something wrong? Like the transfer, like, you know, we have in this here, we have like word by word. Here we have like semantic, syntactic, morphological. So it's kind of like the resource grammar library is somewhere like in these lower levels here, whereas application grammars are like anywhere on, I don't know, anywhere on this level, and it's just using this level as a library so that we don't have to reinvent this wheel every time. So we can define application grammars on exactly that level of semantic correspondence, translation equivalences as we want. So.
So when you're parsing, what happens with parameters that do not exist in some languages?
Oh, I mean, that's that parse. I mean, parameters that don't exist in some language. That's like completely compiled away. Like, I mean, it's like that's not like parameters are not in any form relevant to the abstract syntax. So like. If we think that, like, I mean, that's really the beauty of GF as well, because like if this was a context-free grammar, like this is like, I mean, this is literally a dump of the compiled toy grammar that just does this. X is commutative, X is not commutative, and like if this was a context-free grammar, like we would have to somehow like connect, this thing and that thing and stuff. But the fact that like we are just you know, the parameters, like the parameters exist in the resource grammar library definitions, like how whatever parameters exist in CL that make sense for French, like for instance the subjunctive mood, which English doesn't have. I mean, okay, it has, but it's very marginal. They are all compiled away. So parsing just makes sure that, okay, like parsing is per language, but it's not in the abstract syntax at all. Do you want a more specific answer, or?
But then I don't, for instance, if I have a parameter that exists in one language and another parameter that exists in another, and this is not here, this is not here, and the abstract element does not contain both of them, then how do you transfer information from one to another?
I mean, it might be, okay, like, I mean, it could result in ambiguous parses. So like if we, like, you know, Finnish doesn't have any definite or indefinite articles. So if we, like
some strange inflections that might exist in one language but not in another, like strange forms of forming numbers or.
Oh, I mean, yeah, like, okay, you mean something like, okay, let's say language has a dual. So if you say like, I don't know, like my car, my, like, I don't know, my house is, but then we have a language that says like, okay, my eyes has to use a dual form because I have two of them. So then it just happens so that like in that language that has such a grammatical distinction, we say that like the link at noun has something like, so that number for the language where eyes has forms like, yeah, singular, dual, plural, then this is just, there's three options here, like it's a 3-valued inflection table. And then in, like, okay, you know, in the abstract syntax of the resource kernel library, there is a rule that lets you take a pronoun and make it into possessive, and then, like, you know, a pronoun and a noun, and then possess that noun by that pronoun. And then what would happen is that maybe these words that like govern the dual, they would have an inherent parameter in that language that says that, when we do this, make sure that it's in dual. But it's just like, it's completely unrelated to, because like when we parse English, like we just say, my eyes, okay, we know that this is like, I prawn, and this is like, I just, those are pronounced the same, but like, I don't know if I'm still not answering a question maybe, or.
Yeah, just that it seems like there can be some ambiguity sometimes, depending on the structure of the language that you might, I mean, I think that for some structures you might need more extra information that maybe I can discuss in.
I think it's just.
I can ask you about.
Yeah, we can take it offline, but I think, I mean, the pitch I'm giving here is that like there are many things that are completely language specific and they do not need to be in the abstract syntax. And I can say with the legitimacy that like we've been doing this for 25 plus years and we have quite a few languages there, and like it's been working so far. So we don't need to have, like, our abstract syntax trees are more abstract than your competitors' abstract syntax trees. That's like, I can say this with confidence. So, but yeah, we can talk about it later. That's a good question.
Any other question?
Thank you very much for the talk. I have a bunch of questions. I will try to ask questions that are interesting to a general audience. So one thing, maybe just because I don't have the perspective of like this grammar engineering with multilingual things, could you just tell a bit about like what are the main challenges, like some interesting challenges you faced when doing this, just so maybe we can have a bit of perspective what this like entails in practice when you really try to do this.
I think, like, I mean, obviously I'm very biased here because I've been using GF for 15 years, but like, I mean, some pain points for sure are just like things that, I mean, like the thing that Adrian said, that like currently if you want to add new things to the grammar, you have to recompile and it takes a long time. So it's like I think all the pain points I think of are like in this very practical software engineering sense of like, okay, I get it. Like people who are into GF, they are more of these research type things who are either like into the linguistics like me or who were super into the cool types. And like, as for more linguistics, I think like there are ways in which the grammars can get heavy quite easily, and I would love to, like, I mean, I'm pretty good at like doing non-obvious optimizations at this point, but like it would be very nice if the GF compiler did those automatically. I guess I should not start talking about like syncagrammaticity or something, but like it's.
So these are the like, okay. I think I saw a blog post of yours like talking about like how many parameters certain things can have huge implications. So it's things like this.
Yeah. So
where you end up having to do a lot of engineering. Okay.
Yeah. So I mean, they are definitely things that like large grammars can get very slow. I mean, that there is ongoing work. Like Krasimir, who is like, I guess the main engineer person at the point. Like he's been working on it for the past 4 years, but he has a lot of other duties. So like, it's yeah.
If I can, one more question.
Yeah.
So I remember Anna at some point was talking about like hybrid approaches, so like mixing in like more statistical methods, machine learning methods. What are your? I mean, this is like something that's a huge topic and it's rapidly changing and so on. But could you just like comment on it, like your perspective on this? Like, do you think this is something interesting? Or?
I mean, for me personally, no, because I came from linguistics, and I think like the most fun thing is that I open a grammar book and I read it and then I encode it in GF. But I can say one thing that I was thinking of also at Adrian's talk when he was saying that like, yeah, like, you know, the LLM is most of the time now the LLM is producing syntactically correct. Oh no, he said all the time it's syntactically correct, and most of the time it's semantically correct. So I mean, Arne has this approach that if he gets some, he tries to auto-formalize something, or he gets some output from the LLM, and then so LLM auto-formalization, and then he would use the GF informalization, and then a human could look at the original human written text and compare it to the LLM to formal to GF informal. I think that sounds like a very good. I think that's a very smart approach. That like, you know, it will help you. The fact that like the informalization is a total function. That fact will help you a lot to like easier to compare that to the original human written that was auto-formalized.
Okay, thank you.
Yeah.
Any other question?
I mean, I started 10 minutes late, so it's like right now I'm gonna. No, I've had my hour. So.
Oh, thank you for your talk. Maybe you explain. I hope I didn't miss it because it's a lot of new stuff.
Oh yeah, no.
For me,
sure.
how do you, mainly at the abstract level, can you say a little some words on how do you use? How do you handle equivalences between different? For example, imagine if I want to reason about like sentences that are equivalent in some way. What kind of tools can I use in the framework?
I mean, I think like my answer is going to be a bit boring. Is that like all of these, like whatever is equivalent is just in terms of a given grammar. So it's like we don't really have. I mean, if you want to, like, I mean, I don't know if you want to reason about things that, like, you know, you have one grammar that parses one set of sentences, another grammar that parses another set of sentences. I mean, there is. GF has no way of, I mean, okay, GF has technically, I mean, this very grayed out thing, like there are remnants of a thing that like GF, you can say in GF that like these things are equivalent, but I think. Yeah, no, because I mean, I didn't say, because I mean, the thing is that like these things exist in the core language, but if you want to write a GF application and port it to any other like user-facing applications, these are not supported in the in our bindings to other languages or our more efficient C runtime, and like so they are kind of more of a toys at this point. If you just want to play around with GF in your own shell, like, I mean, yes, they exist, but they are just not ported to other applications. So.
Thank you.
Sorry, I'm not here. Are you saying something? I don't hear.
Okay, so given that we're at the Malinka kickoff and it's about math, and GF is one of the prime tools for handling the complexity, how do you, from an RGL engineer perspective, see the fact that, well, Arne has said he is going to work on math grammars until his retirement. And so we have an Arne math grammar, we have Shashank's math grammar, we have Adrian's math grammar, and Frederick, my student, has currently 2 grammars that he's pursuing.
That's great.
What are the chances of going towards a math resource grammar?
Yeah, I mean that's what Arne has been saying, that like that's his vision for Informath, that it is like, if this is the resource grammar and then just like Informath is built on using these things, and then I mean, I would easily, like, you know, I think what I'm envisioning is more like, okay, if Arne builds his Informath and it's really good, then maybe Frederick can re-implement his grammar using Informath as a library. So I think it's just
grammars
all the way.
Diverged on purpose.
Oh yeah, I mean, well, that's 100%
more
valid.
Semantic.
But I mean, that's perfect. I mean, that's exactly what I mean. I mean, it's grammars all the way down. So it's like, okay, we have, like, you know, the RGL, then we have the Informath, and then we have Frederick's grammar is like here or even here. So that's great. I mean, like, you can, like, I mean, obviously, if maybe he does find it more fun to write his thing from scratch, then that's perfect. But also, if he feels like, oh, actually, you know, actually maybe Arne has implemented these things, or maybe he's like, oh, this is so tedious, I wish someone had implemented a resource grammar for maths, then we'd like, oh, we have it here. So I think it's all very compatible. So.
There will also be some, I don't know, social engineering there. Who will support that? Will that be supported by Malinka?
I mean, I don't know. I'm gonna be here. I mean, I think I can promise to support it until I retire. Like that's some like. Yeah. I think, I mean, retirement ages are going up, so like maybe by the time I retire, it's like, you know, 40 years by now. I don't know. But yeah, that is possible. Oh, that's true. Yeah. We're like, well.
Okay, let's thank the speaker again.